goodness me. Good evening. Welcome to tonight's live stream for AQA GCSE Geography Paper 1 on the 13th of May. Sorry for the delay, guys. Yeah, a little bit of a technical hitch with the cameras, as you've just seen at the start of the live stream. But yeah, we're all good now. We're all up and running, and we're going to have some fun tonight. So we're going to revise question 3, UK coasts. And I want to run through a few key things that I think are going to be on the paper this year. But who's in the chat? Say hello to us. Who is in the chat for the live stream tonight? Say hello. Give us a wave. Hopefully you've got your cup of tea ready. Yeah, there you go. Maybe you've got a coffee. Maybe you've got... No, you can't have energy drinks. You're not allowed energy drinks. Can't have energy drinks. But what have you got? Let's say hello to the chat. So, Mod. Hiya, Mod. Thanks for joining us. Appreciate you dropping in for the live stream. Tay, thanks for joining us. Taywo, thank you for joining us. Lovely to see you again on the live stream. A regular. Speaking of regulars, Fred, thanks for joining us on the live stream, Fred. Frederick is always here doing his geography. Cody, yes. I know you said today, see you on the live stream tonight, sir. A man of your word. You are here. Yes, good stuff. And James and Sophie and probably Dad as well in the background. Thanks for joining us as well for today's live stream event. Who's this? We've got Corey. Nice to see you, Corey. Thanks for joining us. Lovely to see you in the chat. Nikki's here. Is that my Nikki? Is that Nikki in my class? I don't know. If it is, good to see you. Thanks for joining on the live stream. Mr. Chomp is in the house. Thank you for dropping in, saying hello. Wow. Quite a few of you dropped in today. Thank you. I'm sure we'll get more as the live stream goes on. So today's live stream, I say, is UK coasts. I absolutely love coasts. Lots of diagrams, lots of key processes to discuss. What do you need to know for coasts? Main things are processes, coastal processes of erosion, transport and deposition. Check out a previous live stream that I've done on coastal processes. This one's not going to go into too much of that area. Landforms, a massive section on landforms tonight, looking at various different landforms that form at the coast. Coastal management is massive every single year. Make sure you know your sea defences from your sea defences. Okay, I don't know. Make sure you know your sea defences anyway. Really important every single year, the different names of sea defences and how they work and how effective they are. And I think this year as well is going to be MEDMRI, Sustainable Coastal Management. So stay tuned for that one. That'll be Monday of the holidays. We'll do a special live stream on MEDMRI. Right. Everything we do tonight is on a quiz at the end. Stay tuned for the quiz. Let's see who can smash their revision. So we're on a countdown. You've got 1 minute to make sure you've got some coloured crayons. You don't need a ruler, really. Coloured crayons, a highlighter, a pen, and your revision notes. Obviously, if you join the live stream, I use a piece of paper, but you can use lime paper. Make sure you've got a revision book. Hit that like button as well. Cheeky little plug. Hit the like button. It does help to push the content out of the channel to other geographers around the country. Why do we want other geographers to watch these videos? We don't want to give them an advantage, do we? No, we're only joking. We do. Yeah, push that like button. Hit that subscribe button if you're not subscribed. And the notifications so you know when I'm live. 6 p.m. every Monday until the last exam. We are here, including holidays this year. Crazy. Hi to Maddie, thanks for dropping in, Maddie, and Sadhu, well done, thanks for dropping in, and Jar as well. Thank you, Jar, for dropping in on tonight's live stream. So it's all good stuff tonight. It's physical geography, it's paper 1, it's year 10 content, and it's UK coast. So let's get down to business. Let's just share the screen of my live stream paper. Let me just get myself set up here because we did have a few technical issues at the start, guys. But now I think we are good to go. I'm going to try and get a bit more light on the situation here. Okay, there we go. A little bit more light. So I'm going to fit all my notes today on this page. That's the challenge. Your job is to just fit it onto your notebook, really. and see where we're up to by the end of the live stream. So here we go. It is physical geography. Oh, absolutely love it. Physical geography. It is paper 1. 88 marks in the summer. It is on the 13th of May. So this revision is for your first exam on the 13th of May. And that is in the morning, AM. I don't actually know what day it is, but yeah. It's in the morning. Probably like a Wednesday or something. I don't know. What else do we need to put here? This is for Q3. Q3, and it's coasts. UK coasts. So how the live stream work, guys, is you can answer questions in the chat, get involved, join in as much as you can, and then just make some notes. Okay, so things we must revise. Let me just zoom in over here. So these are things that you must revise from your revision guide or from your online revision. Must revise for Q3 coasts. And what have we got? So coastal processes come up every single year. Just a bit of revision, guys. Hit us up in the chat. What are the 4 types of erosion? What are the 4 types of erosion? Let's see who is with Sir tonight on revision. Erosion, transport, and deposition are the main processes for both rivers and for coasts. So make sure you know your coastal processes. Coastal processes of erosion, transport, and deposition. Other things you're going to need to know. I think you're going to need to know this year constructive and destructive waves and what the different characteristics are. It's not been on for a couple of years. It's looking likely. Constructive, destructive, and constructive and destructive waves. Let's have a look. Abrasion, attrition, hydrocation, and solution. Mr. Chompy, you are in first place. Well done. Well done to Frederick. Well done to Tay. Well done, Sadhu. And well done to Sophie. Well done. Right, let's go for another one. What are the 3 types of transport of rocks in water, whether it be a river or a coast? What are the 3 types of transport? Get those in the chat here. So constructive and destructive waves. I think we're going to have weathering and mass movement. Not something that's been on for a while. Weathering and mass movement, we think, is more likely to appear this academic year, 2026. Then, obviously, your sea defences. Sea defences. Oh, I've missed one out, actually. Landforms. And this year's landforms, we think, are more likely to be depositional landforms. Landforms created by sand being deposited. So I'm going to talk about those in tonight's live stream. And then last but not least, case study of sustainable or soft engineering. So soft engineering case study. So we think for us, it is Medmery. Check out the live stream next week, which will be all about Medmery's managed realignment. So that is this year's hot list. Hot list of revision. Get your revision guides out. Make sure you know these topics. These are more likely to come up in this year's exam. How do we get on with the transport? Saltation solutions. Cody. Yes. Legend there. Well done. Absolutely right. Traction. Rocks roll. The largest rocks roll. Suspension. Rocks are carried like sediment in the water column. Solution. They're dissolved into the water column. And then saltation. Rocks bounce along the seabed. Someone's already told me about constructive and destructive waves. Here we go. Constructive waves have a stronger swash and a weaker backwash. Well done. While destructive waves have a weaker swash and a stronger backwash. Correct. So we are going to start there, actually. Let's start with wave types. So absolute legend is Taiwo. Well done. You've got that right. There are a few other differences. So hit us up in the chat, guys. What are other differences between constructive and destructive waves? What are the other differences between constructive and destructive waves? So we're going to start with our constructive waves. Don't worry about fitting it onto a page. If you just make your notes. Constructive waves. Okay, we'll do a little bit of clip art here. So constructive means construction. Constructive means they build beaches. Okay, so constructive waves build up the beach. Okay, they have a very powerful way of building up beaches. So let's have a quick look here. So in terms of constructive waves, we have deposition. This is kind of key here. Deposition is greater than erosion. Okay, so these waves deposit sand more than they erode it. So deposition is greater than erosion for these types of waves. Okay, hit us up in the chat, guys. Any other differences between constructive and destructive waves? I'm going to come to you in a minute. So that's why they build up beaches, because they deposit lots of sand. I'm going to put here deposit lots of sediment, which is what we call sand and silt and clay and all that sort of stuff. That's what they do. So let's draw our constructive wave little diagram here. Here we go. With the beach. There we go. Beautiful. So let's have a little put here that they create gentle sloping beach profile. So on a constructive beach, the beach is very flat, has a very flat profile. If you've been to Skegness, the beach is very wide, it's very flat. They create huge beaches. They build beaches. So the gentle sloping beach profile. Right, they have a very strong, I'm going to come to answers in a minute. I'm just going to put this one on from, tell you what, that should be an arrow, guys. They have a very strong swash. They have a very strong swash. So I've got a really large arrow there. Let's give it a little bit of a colour. There we go. We've got a strong swash. Swash is when waves push. In fact, let me just put some sediment onto the beach there. Yeah, they push rocks onto the beach. It's the forward movement of a breaking wave. Swash. It's a word that sounds like what it is. When a wave breaks, we get swash. Swash. And it pushes sediment onto the beach, okay, as that wave breaks. They have a very weak, so we're just going to have a thin arrow here. They have a weak backwash. Weak backwash. Okay, so they have a weak backwash, they have a strong swash, and let's have a little look at some other features of these waves. So they've got a very long, so from one crest, so one top of the wave to the other, that's a crest. And then between that is called the wavelength. They have a long wave length. Yeah, so they tend to be quite spaced out, quite flat in their profile. They have a very long wavelength. Let's have a look what else we've got. Constructive build beaches, destructive erode. Well done. Wave height and frequency is different. Yes, how are they different? Destructive waves are taller and more frequent. That is correct. Well done, Mr. Choppy. I'm going to talk about that in a second. Long wavelength. And then from the trough, which is here, they have a low height, low wave height. So what I'm saying there is those waves are not very tall. They're very spaced out. They're very flat in profile. They have a very strong swash and a very weak backwash. So just some other key features about this type of wave. Let me zoom out slightly. There we go. A couple of key features. They are low in frequency. So there aren't that many. If you were to count them, they're not that many. They're low in frequency. Roughly less than 8 per minute. Yeah. So they are less than 8 per minute. And typically you would find constructive waves in low winds. So when we've got low wind speed or / summer months. So we tend to find our constructive waves where there's low wind speeds and in the summer months. You might also say low energy. So when there's lower energy, in terms of low wind means lower energy. Okay, that's our constructive waves. They build, they change to an elliptic. Ooh, they change. Have you been Googling? Is this AI? Is this AI here? I don't know. This is pretty good. Their motion is elliptical, whereas destructive is more of a circular orbit. That's impressive. That's really impressive. Yeah, should we add that? So it's more egg-shaped is the movement of the water. That's what I mean by elliptical rather than circular. There we go. I've put the water particles in. This would be really geeky, guys. Mr. Chompy is very geeky here. So we can put an elliptical orbit of water particles. That is super geeky, but very good. You should be doing A-level geography, by the way. We do coast. That is a very smart thing to say. I am impressed. Right. So that's constructive. Let's do our destructive waves. So I'm going to go underneath. Screenshot now if you need it. Oh, we haven't got much space for this one, have we? So destructive waves. By their nature, they destroy beaches. So let's just highlight our destructive waves. They erode beaches / coastline. So they'll erode the cliffs. They will erode the beach. They are destructive by nature. Okay, they erode the coastline. So let me just move that for a second. So let's have a little look what these do then. Erosion. The process of erosion, removal of rocks, is greater than deposition. So they erode more than they deposit in terms of rocks. Erosion is greater than deposition. Okay. I enjoy doing a bit of geography revision. I do think it's fun. Right, let's draw my diagram of the beach. So we need to get a very steep. So they have a steep beach profile. So the beach is much steeper than constructive waves. Yeah, you can see it sloping up there. Very deep, very steep profile. What you also might find is that the beach may be shingle, like rocky, shingle or pebble beach. Yeah, where you got lots of erosion. Whereas this one, maybe you should put it up here. This one's more likely to be sand. Yeah. So constructive waves tend to build sandy beaches, whereas this one tends to be more shingle and rocky by nature. So let's get our waves in. Oh, destructive. Look at that. They're all very close together. And they do tend to plunge, is a word, which means they drop onto the beach. They plunge. And they like scoop the sediment and take it off the coast. Right. Here we go. Big arrow for backwash. Under gravity, the sediment is ripped off the beach and taken offshore. So they have a strong backwash. That's really important. I know someone said that really early on in the chat. They have a strong backwash. They also have a short, look at that, short wavelength between one and the other. Let's put the waves in. They have a short wavelength. Let's squeeze it in there. Short wavelength. Okay. Not the neatest bit there. They also have a taller height, which someone did say in the chat. So let me just rotate it a little bit. Tall wave height. So these waves are higher. They're high energy. They're often associated with, we're going to talk about that, storms and things like that. They have a very weak swash. Just a little arrow there. The forward movement, as I say, they don't tend to swash up the beach. They tend to plunge and rip that sediment off the beach and erode it and take it offshore. So they have a weak swash. Okay, and they tend to plunge onto the beach and remove the sediment. So these waves are typical in, let's just go back to this one then. So these are high frequency waves. Where should I put this here? High frequency. So you tend to get more than 10 per minute. That says plus 10. Sorry, plus 10 per. So you tend to get more than 10 a minute. Okay. So they're high frequency. There's lots of them, lots of energy, hitting the beach, eroding the coastline, forming lots of things like caves, arches, stacks, stumps, wave cut platforms, all that good stuff. High frequency. They tend to be in winter or when we have storms, strong winds. Yeah. So these are high energy. Maybe I can put that there. High energy waves. That's because the wind, they occur when it's strong winds. High energy waves. Revision doesn't have to be beautiful. It's a good job, isn't it, really? Mine's not that beautiful here. It just needs to have a purpose of recapping things. And going back to this point here, they tend to, water particles move in an orbital motion. Water particles move in a circular motion. Yeah. So in a destructive wave, they tend to move in like a perfect circle. The water particles do. Okay, this could be anywhere like the southwest England. We could have had these ones. Eastern England tends to have a lot of constructive waves. But yeah, southwest England, Cornwall, Devon, lots of destructive waves. We do think that that could play a part in our exam this year. So we should tick these off. We've done the first one there, look. We've done constructive, destructive. I now want to look at weathering and mass movement in our next little section. Okay. So, weathering and mass movement, then we'll do sea defences and landforms. Okay, happy with that? Let's have a look, catch up with the chat. Destructive waves have height, yeah. So they're much taller. Good. Destructive waves are steep, yeah. It's Kinde. Sorry, Kinde. Destructive waves have a higher frequency and a tall profile. Well done, you. Right. If you're doing the exam and you're in this live stream, I am happy with what you know. Your knowledge is very good. Right. So I'm just going to go up to the top now, guys, and we're going to look at weathering and mass movement. So let's have a little look at this. Now we might be a bit rustier, I don't know, on this area. I've just kind of dotted it around so I can divide it up a little bit. Okay, let's start with weathering. What is weathering? Who can tell me in the chat what weathering is? What is weathering? Okay, weathering is the breaking down of rocks. Correct. So let's get that in there. Let's just zoom you in a little bit. Move you a little bit this way. So weathering tends to occur on the tops of our cliffs. It is the breaking down of rocks in situ, usually at the top of cliffs. Okay, so tops of cliffs, which is also known as, if you're going for grade 7 and above, sub-aerial processes. Oh, wow. Which basically means it occurs on the top of cliffs. So these aren't things that are caused by the waves. Sub-aerial processes. Let's get that highlighted in yellow here. These are things that happen at the top of the cliff but play a part in the coastal kind of environment, because the rocks from the top of the cliff end up at the bottom, and that helps with erosion of the base of the cliff. So sub-aerial processes. So can you name the three types of weathering? What are the 3 types of weathering? Because we're going to have a little look at these 3 types of weathering. Kehinde is in there very, very quickly. And if you don't know, well, you're in the right place, because we're going to go through them. We've got biological, chemical, and mechanical. Well done. What have we got here? Burrowing animals. Mr. Chompy, I don't know if you're whacking it in from AI here. I don't know what's going on. This is pretty good. If you don't, this is really impressive. Breaking down of rocks and landforms. Yeah, good. Well done, you. If this is your knowledge, that is really impressive. Right, let's have a little look then. So first one we have is mechanical. Mechanical or physical weathering, it's called. Okay, mechanical or physical weathering. That's a little slash there. Sorry, guys. Mechanical or physical weathering, also known as freeze-thaw, freezing and melting, or what we call freeze-thaw weathering. This happens on cliffs around the UK, especially in the winter months, like January to about April time. We get a lot of freeze-thaw weathering. Right, time for a diagram, guys. Here is our diagram. We have rocks here at the top, and they freeze. So rocks on the cliffs. Here's our rocks. There we go. And here is our ice. Yeah, it's frozen. And water gets into the cracks in the rocks and it freezes. And the ice expands by 9%. So if you freeze water, it expands. Yeah, just be careful with this though. Put a bottle of water in the freezer, it will expand. Okay, it might even pop the top off if you're not careful. It expands, it stresses the rocks. So it rains, it freezes in the cliff, and it stresses the rocks, and then they expand. Then what happens? Eventually, when it heats up, it contracts and breaks the rock apart. Okay, so here we've got so expands there, then it contracts with the cold, and then expands again. So this constant expanding, contracting, expanding, contracting will break the rock apart, and that is called freeze-thaw weathering. It happens to our cliffs. The rocks then end up on the beach at the bottom, so they fall off the cliff. It's a sub-aerial process. It happens at the tops of our cliffs. We get this freeze-thaw weathering. In fact, let me highlight that. Freezing and thawing, expanding and contracting, expanding, contracting, and then the rock breaks apart. Right, okay, that's freeze-thaw weathering. Right, let's have a look at the next one. Chemical weathering. Again, this happens as a subaerial process at the top of our cliffs. Chemical weathering. Somebody mentioned acidity. I'm going to give you another posh name here. It's also known as, for my higher grades, carbonation. Carbonation, which is a process that happens. And this happens on carboniferous rocks, usually limestone. So this type of weathering happens very often on limestone or chalk cliffs, like we find at Flamborough in East Yorkshire. So carbonation is when the rainwater is maybe slightly acidic rainwater, maybe from like pollutants that are in the atmosphere, and it's probably only about pH 6 at maximum. Not really acidic or anything like that. But then what happens is it hits the limestone, lime being alkaline, and what it does is it starts to dissolve. It starts to dissolve the limestone. Yeah, so this rain, yeah, I've put it in red. It's not actually red in real life, but it just so it's been dissolved away. So limestone, which is pH towards 8, it's alkaline, will dissolve. That's the key thing. So our cliffs can dissolve, especially if they're made of chalk or limestone, by the slight acidity of rainwater. Yeah, and that's called carbonation as well, which is a very good term. Last but not least, let's go for this one, biological weathering. This is about plants and animals. Yeah, Kinde's got it. Freeze store, water seeps into the cracks, into the rocks. Freeze expands by 9%. And yeah, absolutely, that's what we just looked at. Good man. Mr. Chompy, acid rain is caused by nitrate and sulfur emissions. Yeah, pollutants. Yeah, absolutely. From pollutants like that, from vehicles, makes it slightly acidic, and then that will dissolve our carboniferous rocks, such as limestone and chalk. Right, I think we're getting on to the one that you're talking about now, so I'll put that on in a second. Right, here we go. Biological weathering is to do with plants and animals, basically. Plants and animals, anything living that can break the rock apart. Remember, weathering is where rocks break apart in situ, in position. So let's have a little look at this then. So this is things like burrowing animals. Yeah, usually like a rabbit or something at the tops of cliffs. And then things like tree roots. Probably doesn't mean much to them. Let me just get a bit of colour on here. So here's the top of our cliff here. Yeah. And there's our tree. Let's put our rabbit on. Let's dig a nice big hole in the cliff where it lives. Also things like puffins and things like that, seabirds. They will dig into the cliff to make burrows. So any burrowing animal, let's put their animal burrow from a rabbit. Often you see them burrowing into cliffs, or things like puffins, animal burrow that will help to break the rock apart. And the tree roots here, look. Yeah, any roots going into the cliff. As the tree gets bigger, the roots get bigger, and that causes the cliff to fracture, and that breaks apart the rock. So roots can break the cliff apart. Obviously over lots of time, but that can happen as well. So biological weathering, animals and plants can break the rock apart. Okay, let's have a little look at mass movement then. Let's have a little think about this one. There are 3 types of mass movement, but do you know them? Okay. Let's have a little look. Mass movement, we think this might be on. What is mass movement of cliffs? Hit us up in the chat if you know what mass movement is. Sulfur, yes, makes sulfuric acid. That is true. Well done, Cody. Very impressed with your chemistry knowledge there. Nitrogen reacting in car engines making nitric acid or nitric acid. Nitric acid, isn't it? Cheers. Yeah, well done. We've got some chemists here. Chemistry comes in. People say that like geography. Oh, it's like science. It is. It is. It's environmental science. That's what you are studying. Right. Mass movements. What is mass movement? Well, let's just get onto this. This is when gravity acts on rocks, shifting rocks downslope. Yeah, so this is associated with cliffs. Sometimes you'll see pictures of cliffs and you see all these rocks that have slipped or slid or slumped or fallen. Okay, and there are main types of mass movement. It's all to do with gravity and gravitational pull on the cliff. So I've got this little space at the bottom here, which we are going to use for mass movement. Okay. So we've got three options. We've got slides. This is where a section of the cliff literally just slides down along a plane. Let's add that there. Put the C in. Yeah, this is our cliff. Again, just remember in geography, you can draw labeled diagrams to show what is going on. So slides, it slides. This is along the plane here. This is the slip fault. This is a sliding fault here. So it slides on a plane, which is a fault line, basically. A bit like tectonics. Yeah, you get these fractures in the rock, and it's like a fault line, and it just slides on that plane. And the key thing here is material shifts in a straight line. So it moves in a straight line direction. It slips away down the cliff face. So that's our sliding or slides. Slumping, which you have to know if you are, let me just highlight sliding. If you're doing the Holderness Coast, slumping is really important. This is how most of the cliffs along the Holderness Coast are being mass moved, as it were, been affected by mass movement. So let's have a look at slumping. Slumping is very different. It's usually to do with water logging. So slumping is this rotational action here, okay? So it's not a straight line, it's rotational action. Let's get the, yeah. And it's usually to do with, and we'll put it at the bottom here, it's usually to do with waterlogging. So the base of the cliff, let me just put loads of water at the bottom of the cliff here, look. Now you'll understand what's happening. We get a waterlogged, you get waterlogging. So basically, it rains heavily, waterlogging, that says. It rains heavily, it soaks to the bottom of the cliff where there might be clay. It builds up a layer of water at the base of the clay, and then at the base of the cliff where the clay is, and it slips because it becomes mobile. Because of the water, it means the cliff is more mobile, and it helps it move. So we've got material moves in a rotational / curved, rotational curved movement. Okay, so it slips because of the waterlogged base of the cliff, and that's what happens there. So slumping, it happens on the Holderness coast. Very common. Big case study for most geographers around the UK. Holderness coast is where you'll find a lot of cliff slumping. It's usually where you have clay cliffs. Let's put that there. So where cliffs have got clay in them, the water builds up above the clay because it's impermeable, and that causes it to become waterlogged. So that's slumping. Right, let's move on to our last one. We're going to go up to the top here. And this one's probably the easiest one. Let's just move that up here. It's called rockfall. Oops. Sort the camera out, guys. Yeah, you should put into your revision guides or your revision notes, you can put those in there. So rockfall, let's put that in. This happens where cliffs are vertical, usually. And this effectively is, let's just put it in there. We've got vertical alignments of the geology. Yeah, and then we just get a rock that falls vertically onto the beach. Yeah, part of the cliff that just drops like that because you get these vertical bedding planes. Here's the sea out this way here. Look, here's the sea. Let's put the sea in. Yeah, the rocks just fall directly onto the beach below. Okay, so rockfall is vertical movement of rocks due to gravity. Gravity obviously pulls them down. That's why they hit the beach below. And we get this normally, this falling of the rocks. So we've had sliding, which is kind of horizontal. Yeah, along a plane. We've got slumping, which is curved. Rockfall, which is vertical. Okay. And we usually get this because we've got vertical layers of rock. Vertical bedding planes. Okay, there we go. We are getting closer and closer to quiz time, but I want to do a couple more things before we get on to quiz time. So let's talk about longshore drift, because I think this could also be on this year. Longshore drift, or LSD, longshore drift. It's not been on for a couple of years. It's a big process. So let's go on to longshore drift. In the chat, guys, tell me what you remember about the process of longshore drift. Longshore drift is the transport of sediment along a coastline. That's what it is. It's the transport of sediment along a coastline. Let's get you zoomed in. What can you remember about longshore drift, guys? Hit us up in the chat. Let's have a little look. The movement of the sediment is zigzag. Yes. You get a mark for that. Zigzag movement. Longshore drift is a process where sand, pebbles, and other material move in a zigzag pattern along the coast. Well done. Waves hit the beach. It carries sediment along the shore in a zigzag pattern. Well done, Jar. Well done, Kahinde. Well done, Sadhu. Prevailing winds. Oh, look at this one here. Mr. Chompy. Prevailing winds hit the beach at an angle. Yes. Swash moves the sediment up the beach. Backwash brings it back down, moved in the water again. Right, okay. Absolutely spot on. Let's get our longshore drift diagram here so we can do some revision. A new wave washes it onto the beach again in a zigzag pattern, moving sediment up the beach. Mr. Chompy, you are going to absolutely break your exam this year by the looks of it. If you know all this, you are very, very good. So waves hit the beach at 45-degree angle. I think that's also called oblique angle. Let's put our beach in. Here is our beach. So over a year or a few years, sediment can move along the coastline. Basically because the waves hit the beach at an angle. based on the prevailing wind direction. So here is the prevailing wind direction. So in ideal situation, the wind blows at an angle to the beach, usually about 45 degrees, or if you're going to be a geeky grade 7 and above, obliquely to the beach. And then it pushes the sediment onto the beach. There we go. That's our piece of sediment. And we get swash at an angle. So swash pushes the sediment onto the beach. This orange piece is our rock. That's our rock there. And then backwash at 90 degrees to the coastline. Yeah, you can see it's a 90-degree angle there. Look, if I put a little angle sign in there, there you go. That's a 90-degree angle. So at 90 degrees, backwash brings the rock back into the sea. So there we go. That's our backwash. Let me label it here. Backwash. Gravity is what pulls the wave back into the sea. Yeah, gravity, backwash, and gravity pull it back in. And then we get another wave coming in. Again, which will swash it back onto the beach. There we go. And it'll then come back off the beach as backwash. And then back on the beach as swash. And this repeats itself. And we get a zigzag pattern, which is definitely worth a mark in the exam. Yeah, it moves along the coast in a zigzag pattern. There we go. And that is, maybe we should put an arrow at the top here. That is longshore drift. That's where it's moving. Longshore drift. Okay, heads up in the chat, guys. What sea defense is built to prevent longshore drift? What sea defense is built to prevent longshore drift? Who can tell me as quick as you can? Do we have fieldwork that we can look at for longshore drift in year 11, or is it at A level? In A level, JAR, you go to the coast. We measure longshore drift in A level geography. So if you've signed up for that, then you'll get to go to the coast. Let's have a little look. Spits and bars. Yeah, I'm going to talk about these weird names, which is it connects the islands. Yeah, I'm going to talk about that next. Spits and bars. Excellent. The other one is an island. Yeah, Tombola is the one you're thinking of. I'm going to mention those three in a minute. Tombola. Hopefully we get time on today's live stream. Groins. Well done, Jar. Groins. Well done. Groins. Groins intercept waves and on the beach, storing the sand on the beach. Correct answer. Groins. Yeah, well done to everybody who said groins. Superb. You are spot on, guys. Right, there is our longshore drift. Well, longshore drift can be create some stunning landforms, such as spits, bars, and tombolas. So let's have a little look in this final corner here at depositional landforms, which we think could be on in 2026. So here we go, depositional landforms. Landforms created by adding sediment from the eroded cliffs that we've already spoken about previously due to mass movement and weathering, plus hydraulic action, abrasion, and attrition. So in depositional landforms, we have, I'm going to start with bars. We have spits as well. And we have tombolos. So there are three landforms that you need to know. We're going to start with bars. Okay. So what is a bar? It is a ridge of sand. It's a ridge of sand. That's what it is. A ridge of sand that connects two headlands together. So it's a ridge of sand that connects two headlands together. formed by deposition. So here we go. This is what a bar looks like. So here is our headland 1. Headland 2 here. So these are 2 headlands that are now joined together by, here is our bar, our ridge of sand. Let's put that on there. Just add a bit of colour so we can see what is going on with what. That's our first headland. And our second headland. And then behind it, we get salt water trapped. So that will form a lagoon. A lagoon is a saltwater like pond or lake. Pond, basically. It's like pond size. It's a saltwater lagoon, basically. It's called a lagoon. Just call it a lagoon. It's fine. There's our bar. And it's caused by longshore drift. Yeah, sediment being pushed along, formed by longshore drift along the coastline. Longshore drift. It continues in a straight line, depositing sand from one headland to another, and that is a bar. We do have a famous bar. No, not Wetherspoons. Our famous bar that we did was Chesil Beach. Chesil Beach, which is in Dorset on the Jurassic Coast. Chesil Beach is a really good example of a bar. Okay. Lagoon forms behind the bar. Absolutely. Yeah. That's a really good saltwater habitat. So if you're into fish and seabirds, that lagoon there is a really good place for our habitats, for our animals and biodiversity, plants and animals living in that lagoon. So they form over many, many years. Longshore drift continues in a straight line along the coastline, connecting 2 headlands, and that is our bar. It's a ridge of sand connecting 2 headlands. Right, let's go to, I'm going to have to change my paper now, look. Well, look how good that is. I'm well happy with that today, look at that. Love it. All key things that we think we're going to need to know in 2026 for question 3. Right, I'm going to swap it out for another piece. There's a couple of things I want to do. I want to do spits and I want to do tombolas as well. Right, so I'm going to go head up to this bit here. I might use this next week and finish it off with memory on the same sheet here. So here we go. Let's do our spits. Probably the one that you're most likely to get this summer, I think. I think they're going to ask you about coastal spits and how they actually form. So let's go to our spits. And we'll draw a little diagram of what it is. So spits. Let's just bring it over a little bit where it's a bit lighter. Spits are a depositional landform, depositional hooked shaped landform created by longshore drift. Longshore drift. So they're formed by longshore drift, and they are a hooked shape landform made of sand and sediment. Okay, they are a depositional landform. Okay, that's our spit. So let's have a quick look at a spit. There's a couple of key things that we need to know about spits. They often form near the mouth of a river. This is going to be our spit here. Beautiful hook shape. Yeah. So there we go. They form by longshore drift. Yeah. So let's put our longshore drift on. A little zigzag pattern. So we've got longshore drift here. Sediment moves down the coastline until it reaches, it's actually an estuary, but the river, let's put the river here, river estuary. So it's where the river's starting to flow out into the sea. That's where we get River estuaries. We're going to talk more about that on another live stream when we do rivers. Yeah. Okay. But they where the mouth of the river is. They form where, this is really important, guys. Let's put the land in. They form where the coastline changes shape. So where the coastline goes inwards, where there's a river estuary. So they form where the coastline changes shape, such as a river estuary. Okay, so they form where there's a coastline change shape. Longshore drift continues in a straight line. In a straight line, depositing sediment, which is rocks, sand, silt, depositing sediment across the mouth of a river. So longshore drift continues in a straight line, depositing sand across the mouth of the river. So let's have a look what makes it a hooked shape. Who can tell me in the chat, guys, why? Oh, someone's named one actually. Spurn Point. Spurn Point is a good example. Let's put it down here. E.g. Spurn Point is a really good example. That's in East Yorkshire, is Spurn Point. On the Holderness coast, actually. Why do spits hook? What causes the hook shape of a spit? Spurn Point is in East Yorkshire. Thank you for all contributing. I can see the little crowns actually in the chat. It's really good. Yeah, Spurn Point is our one. Right, okay. Why does it hook round? It is changes in wave / wind direction. Yeah, if the wind changes direction, the waves will, and that will cause it to shape it, like carving out the spit. It will cause it to hook around. So changes in the wind and wave direction will cause it. Also, things like rip currents and tides also help to shape the spit into a hook. So tides, rip currents, wind, and wave direction all help to shape it. Now, I've deliberately left it a little bit white behind it because here is a very important feature. What feature forms behind a spit in this sheltered area here? What feature, which beautiful natural landform will form in the sheltered zone behind a spit? Often characterized by wildlife. Let's get my little, yeah, that's a little wildlife there, a little wildlife sign. So what is this feature here? In the sheltered zone of deposition, what do we get in that sheltered zone? What is this feature? Anybody know in the chat? Okay, this is known as a salt marsh. It's a salt marsh which forms behind the spit where energy levels are low, where it's sheltered. The water is not really moving around. We get lots here of mud flats. So we get the buildup of mud deposits, and salt tolerant plants. So plants that like salt water, salt tolerant plants grow. And that helps to stabilize the spit. Any plants actually help to stabilize the spit. So often our spits have got plants on them, and that helps to stabilize them. The roots kind of hold the sand and sediment in place. So I do think you're going to get spits this year. I've got a big feeling about this one. Depositional landforms, spits is a good one to talk about. Lots going on there with the shape of our spit. Right, last one. One that most geographers do forget about is the tombola. So we're just going to talk briefly about a tombola. Yeah, here's our tombolo. What can we say about tombolas? Have I got a little definition here as well? It's not even in the book here. We don't need the book anyway. Tombola. This is where, let's draw our land in. So we've got longshore drift, and then we have an island. So let's put our island in. So it's got a rock island here. This one is actually Portland. And then we have our sand moving in from different directions. They are really beautiful tombolas, huh? Let's put our, there we go, that's our sand moving in. This is our coastline and the sea. So tombolas are stunning. It's when the land or the beach connects the mainland to an island. So they are a depositional landform caused by rocks being deposited. Depositional landform where sediment connects the mainland, which is here. Let's put the mainland. This is like the main part of the country. The mainland to an island. Yeah. Yeah. So it connects the mainland to an island. And it forms for two reasons. Longshore drift coming in from both sides. Yeah. Longshore drift moves in from both sides and combines in the middle. So we've got longshore drift bringing sediment in. Okay, into this area behind here. And also this area here is actually sheltered. Let's just put that in because the island there, the waves are kind of hitting it from this direction. It's also an area that's sheltered. So the waves aren't very strong. There's a lot of low energy area. So I'm going to put here, it's sheltered zone behind the island. Waves lose energy because it's sheltered, not very strong winds. Waves lose energy and deposit, which basically means drop the sediment that they're carrying. Deposit sediment to form a tombolo. Yeah. So you've got two things happening. You've got longshore drift from both directions, feeding sand behind the island. And then because the island is blocking the waves, it's very sheltered, it's very low energy, and that sand builds up and is deposited. Our example here, e.g., is the Isle of Portland. Is a really good example of a tombola. And this is in Dorset, basically, again. Dorset is a Jurassic coast, and you got the Isle of Portland. It's a beautiful example of a tombolo. So, depositional landforms, bars, spits, and tombolas. Apologies, sir, I have to go now. Thank you so much for coming. It's been a pleasure. You're missing the quiz. The quiz is going to start literally in about 5 minutes. Going to start 18 miles to Portland, I think. Yeah, that's where it is. Yeah, Chesil Beach. Okay. Sorry, I'm reading the comments the wrong way around. Have tombolas ever been on the exam? No, tombolas have never ever been on a geography exam since 2017-18. So there's space for it to come up. Okay, and that's how they form. Yeah, longshore drift either side of the mainland, moving sediment in, sheltered behind the island, it deposits and it connects it in. Really good. Right, I want to do one more thing. Sea defenses, and I want to talk about soft engineering sea defenses. So let's have a little blast out of this for 5 minutes. Sea defenses are on every single year. Know your sea defenses. If you don't, you are going to be stuck for marks. They're on every year. Sea defenses, we're going to talk about soft engineering sea defenses. simply because last year was hard engineering. So chances are you're more likely to get soft engineering sea defences. What do we mean by soft engineering sea defences? Let's come up with like a little checklist. What is soft engineering sea defences? What do we mean by soft engineering sea defences? We'll come up with at least 3 qualities of soft engineering. People are giving me types. I want to know the characteristics rather than the types. Well done. They are natural. So they tend to use sand or plants. Okay, tend to use sand or plants. They are natural. What else are they? They are sustainable. They are sustainable. Okay. Natural and blends in. Yeah. Used in places with sensitive environments. So maybe places where there's wildlife, where there's nature. You can't be building seawalls and rock armor. You might be thinking more of using soft engineering. So sensitive places, such as places that have a high biodiversity. Okay. So places with a high biodiversity. I'm going to say cost effective. So these ones do tend to be more cost effective. Nothing is cheap, is it, nowadays? And the word cheap, like, that's like £1 or something. Sea defences, even these ones cost a few, like tens of thousands. They're not cheap still. So we're going to say cost effective. They get a bit more for your money, probably, in these scenarios. Okay. And they tend to be more holistic approaches. They think about, which basically means they benefit people, social. They tend to be more cost effective, economic, and they think about the environment. That's just short for environment. So for my higher grades, you could say these are more holistic measures of coastal management. That'd be a really good thing to say. They think about people, they protect communities, they're cost effective, and they help the environment. Right, have we got some names of some? Yeah, absolutely. Can you name 2 types of soft engineering sea defences? Managed retreat, beach nourishment, and sand dunes. Yes. Right, so I'm going to talk about all 3 of these, but managed retreat we're going to talk more about on next Monday's live stream when we look at memory. So stay tuned, hit that notification bell, hit that thumbs up, all that good stuff when we talk about those. So let's go with, first of all, beach nourishment. Nourish means to feed the beach with sediment. Yeah, nourishment is about feeding the beach. Also known sometimes as beach reprofiling. Yeah, changing the shape of the beach. So what happens here is we get basically a ship in the water often, which pumps the sand back onto the beach from offshore. So that's where the sand comes from. Oh, sorry, guys, I didn't realize. Sorry, guys. Need to move my camera. Yeah. So we have a large ship offshore that will pump sand back onto the beach like that, adding more sand to the beach. And then we also have things like a bulldozer. Not supposed to be a bulldozer, guys. That moves the sand around to reprofile it. Yeah. So it is adding more sand to the beach, which is a natural. Beaches are a natural barrier to erosion. The bigger the beach, the less likely the waves are going to reach the cliff. So they are a natural barrier to erosion. So let's go for 2 positives and 2 negatives of beach nourishment. Hit me up in the chat, guys. 2 positives and 2 negatives of beach nourishment. We are now about 4 minutes away from the quiz. Stay tuned. Beach nourishment. Adding sediment to increase the size of the beach. The size of a beach. That's what beach nourishment is. Pumping sand onto the beach. They do it a lot in other countries. What's good about this? Yes, it creates a wider beach. So it will reduce erosion, which is what it's designed to do. Erosion and flooding. And it's also good for tourism because you're making your beach wider and bigger. Let's zoom you in, guys. You're making your beach wider and bigger. So it's good for tourism. Attracts tourists. They spend money. Good for the local economy. Yeah, so it's really good in that sense. So it reduces erosion and flooding. It promotes tourism. Have we got any negatives? Great protection from flooding and erosion. Restores habitats. Oh, let's put that in because that's a good one. Restores habitats. That is a good one. Well done to Kehinde. What about negatives? Yeah. It can damage the seabed habitats as well. So it can be destructive during beach nourishment, basically. So when you're actually doing the process, it can be quite destructive because you're having to use bulldozers on the beach. You're using sediment that's been pumped off the seabed. It can damage habitats. It can cover over plants. It can cover over anything that's living there. So whilst it's happening, it can be quite destructive. And it needs, it needs regular maintenance. Regular maintenance. Okay, regular maintenance is important. What have we got for the cost? I haven't got any figures for the cost. How much does beach nourishment cost? Can somebody Google that for me? Mod, if you're there, can you Google the average cost of beach nourishment? That would be good. Right, we are 3 minutes from the quiz. We've got to do one more. As I say, join me next week for Manage Realignment. We're going to do sand dunes. Sand dune regeneration, getting sand dunes to protect the coastline. Sand dune regeneration, it's called. Sand dune stabilization as well. That's why we put the fences up there. So basically how it works is if we have a community, a vulnerable community here, and we build sand dunes in front or encourage sand dunes to develop, should I say, not build them. You don't build a sand dune. Encourage them to develop in front of the community. Yeah. So here are our sand dunes here. They act again as a natural barrier to erosion and flooding. So now here is the sea out here, look. So the community is protected by the sand dunes because the water, obviously the sea out here, can no longer reach them. We've got this natural barrier of sand dunes. The plant that we need to grow is called marram grass. We have to plant marram grass. And then we often have to put up dune fencing to protect the grass as it grows. So we plant marram grass and we add up dune fencing to protect the grass and the sand dunes. Otherwise, they will probably get trampled. Protect the sand dunes. Okay, positives and negatives. Let's go for one positive and one negative of June regeneration, because we're running out of time now. And we need to do our quiz, don't we? We need to get onto that quiz. So, beach nourishment costs £20 per metre cubed. Okay, that's a good price. Thanks, Mod. £20 per metre cubed. So it's very cheap, isn't that? A metre by a metre by a metre costs £20. So again, it's quite cost effective. Can we have a price as well, Mod, for June regeneration, sand dune regeneration? What's the average cost of sand dune regeneration? Stabilize. Ooh, that's good. I love that. Obviously, plants absorb carbon dioxide, so that would help with climate change. Well done, you. Yes. I'm going to put here plants absorb CO2, which then reduces climate change. Well done. So not only do you stop coastal erosion, you actually help to protect against climate change. That is impressive. They absorb the wave. Yeah, that's really good. Tay, the sand dunes absorb the wave energy. Well done. Nourishment is very expensive. It is quite expensive, I suppose, £20 per metre square, but not as much as a seawall. Not as much as a seawall. Right, last one. The problem with sand dunes is they take time to grow / establish. So when you plant your marram grass, it's going to take a while for that to grow and establish. Your sand dunes might take years, 10 years to fully develop. You might not have 10 years to wait before you are protected. So that could be a problem. Right, let's go back to our original checklist. Time to grow and establish. Yeah, let's have a look at our original checklist. Let's see where we're up to. We've done weathering. We've done sea defences. We've done depositional landforms. We've only got Medmery case study to do, and we'll do that next week. Hit that like button, hit that subscribe button, notification bell, and share. And I will see you back on next Monday. Look at that. I'm well happy with that. Look, really happy with that. Looks really good. Thanks for joining me for revision. It's now quiz time. So let's go to full screen. This is the bit we've all been waiting for. It is quiz time. Right, I'm going to share my screen now. Let me just get the Kahoot quiz. Hope you've enjoyed tonight's live stream. Sand dune regeneration. Let me just add that to my notes. Is that also £20 per metre squared? £2,000 for 100 metres, okay? I'm just going to put £20 per metre squared. So same price as beach nourishment. Well done, guys. Really appreciate that. Thanks for that, Mod. Absolutely brilliant with that one. Right, let me get this Kahoot up and running. I don't need to create one. I need to go live on this one. Let's have a little look. Host live. That's what we want. Get rid of that camera now. Let's have a little look. Cut on here. Start that. Right, here we go, guys. Let me share the screen now. Share screen. And there you go. Let's get rid of me for now, because people moan when I'm on the screen because I block everything. So there you go, guys. Drop into that. I am still here in the background, drinking my cup of tea now, which is nice. And I'm going to put the camera away. So if you can join that one. Let's see who has learnt the most in tonight's revision session. Hopefully you're feeling a little bit more confident, ready for your exam on coasts. Question 3 coasts. Join the whole series. We're doing a whole series on YouTube of things that are most likely to appear in 2026 to support your revision. I am just packing a few things away. Right, I think we're ready to start. Anybody else waiting to get in? Do I need to wait any longer for anybody? Mod is in. Love it, Mod. Thank you for joining. The Mod is in the quiz. Any other geographers, mums, dads? Yeah. Join in. Anybody else want to join? Right, I think that might be it. So I'm going to start, guys. Let's have a little look. Here we go. And we're off. High frequency waves, 10 to 15 per minute is correct. They have a strong backwash, those people that put blue. They have a strong backwash and a weak swash. Let's have a look. Oh, very good. Number 2. How does the fetch of a wave affect coastal erosion? Yeah, we haven't mentioned fetch of a wave today, but it's good revision. Fetch. Well done. The longer the fetch, the more energy the wave has. Fetch is how far the wave has travelled before reaching the coastline. Okay, number 3. In longshore drift, at what angle does swash usually approach? Well done. A 45-degree angle. Backwash is perpendicular. Swash is 45 degrees. Kahinde, smashing it. Well done, you. Attrition. That's impressive. You do have to know erosion, transport and depositional processes really well. They are on every year. Whenever you talk about a landform, you talk about processes. Ooh, that could be quite tricky, that one. Well done. Most of you got it right, so well done. Waterlogging at the base of the cliff becomes saturated. So well done to those that got it right. Number 6. Carboniferous limestone and chalk. Carbonation, well done. Carbonation affects carboniferous rocks. Come on, Mod. He's got a degree in geography as the moderator. Come on. Oh, he's studying a degree. A spit often develops a hook due to what reason? Okay, well done. Next one. Oh, there's a beautiful tombola in the picture. What distinguishes a tombola from a bar? Well done. It connects an island with the mainland. Superb. Question 9. Why does deposition occur at a coastal bar? Why does any depositional feature form? What happens? Well done. Energy levels drop and sediment is deposited. Well done, guys. That's a good one. Not everybody got it right. I love it when everybody gets it wrong. It makes the leaderboard more interesting. Tricky question. Oh, you did know it. Well done, guys. Elliptical water motion in a constructive wave. Well done. We're over halfway. Managed retreat is often chosen because... Oh, I've not mentioned this today. I've not mentioned this one. This is on the next live stream. Oh, well done. Sustainable and more cost effective. 12. What is the disadvantage of beach nourishment? I just realised that's not an ice cream. That's the moon or the sun setting. It's a sunset, isn't it? It's a sunset. It looks like an ice cream. Yeah, requires regular maintenance. All right, 13. How do sand dunes act as a sea defense? They absorb the energy of the wave. Well done. Excellent. Right, number 14. Dune regeneration involves planting what? There's a picture as well. That's a beautiful picture. Marram grass. Yes, well done. 15. Which soft engineering method allows the sea to flood the land? It is managed retreat. Well done, guys. Mod is catching up, but will he catch up by the end? 16. Mechanical weathering is also known as... well done. 100% right. Pressure is on. 17. Well done. Vertically jointed rocks. What determines the direction of longshore drift? Yep, the direction of the wind is the same direction that the waves move in. Mod is getting close to winning. Defeat the mod. Oh no, double points. Gotta get this right. Double points. Yes. And loads of people got it wrong. When two headlands join, it's a bar, and behind it forms a lagoon. Oh, Mod got it wrong. Oh, no. And that's meant Mr. Chompy's almost won. Last question. Double points. Which process creates wave-cut notches? Look at the photo. The base of the cliff is worn away, creating a notch. The mod is making excuses here. Abrasion and hydraulic action. Well done. 100%. So here we go, guys. Tonight's live stream. We have Kahinde in bronze position, coastal expert. We have the mods. Well done, mod, in second silver position. And tonight's live stream expert on coast is Mr. Chompy. Well done, Mr. Chompy. You impressed from the start, actually. You were very impressive. So well done to all our live streamers tonight. Join us next week when we look at Manage Retreat and Medmurray, and join us for the whole series up to the last exam. Thanks for joining us. Hit that like, hit that subscribe, share. Have a lovely evening, and see you on the next one. Thanks. Bye-bye now. Cheers, guys.